Look at another interesting problem, number 185, department top 3 salaries. This problem was asked in Google, Amazon, and Facebook, and this is one of the common interview problem. We are given with the employee table, which contains ID, name, salary, and department ID. ID is the primary key for this table. Department ID is a foreign key of the ID from the department table. Each row of this table indicates the ID, name, and salary of an employee. It also contains the ID of their department. Let's look at the department table. It just has ID and name. ID is the primary key for this table. Each row of this table indicates the ID of the department and its name. A company's executives are interested in seeing who earns the most money in each of the company's department. A high earner in a department is an employee who has a salary in top 3 unique salaries for the department. Write an SQL query to find the employees who are high earners in each of the departments. We need to return the result in any order. Let's try to understand this problem statement with one example here. So, employee table contains 7 employees here, and it just have 2 departments. For department 1, which is IT, we need to find top 3 employees who earns the most, and the same for department 2. With this table, for department 1, we can tell 90,000 from Max is the first highest salary. Second belongs to Joe and Randy. They two earn same amount, say they become second highest salary. And third, it belongs to 70,000 from Will. So this Max, Joe, Randy, Will, they belongs to the top 3 salary for the department IT. Now coming to sales department, there are only 2 employees present and they'll become the top 3 highest salary. So there is no third person. So just 2 employees will be present here. This is the problem statement. I hope you understand it. I have created a detailed statement here and put it in the description box. You can make use of it and try to practice in your local. By looking at this problem, the most common and the easy solution is just, join the employees and department table, find and create a normalized table. That will be our first step. So once we have the normalized table, then we just use the dense rank or some window functions, creating a partition on department and finding the ranks in descending order. At the end, we'll be limiting only ranks which are less than 3. That's the most common solution, right? There may be a scenario where interviewer can tell you don't use the window functions. These kind of scenarios will happen they just to test your knowledge and skill, right? If this is the case, let's see how we can solve this problem without using window functions in this video. The first solution, let's make use of the window functions and see how it works, right? Let's start writing our query with base data. Here, first I'll create a normalized table from employees and department. I'll select from employee table E. I'll left join with department table D on E dot department ID should be equals D dot ID. So inside this employee, department ID should be joined with department table ID, right? And then I'll select from the employee table, I'll select E dot ID, E dot name, E dot salary, right? And from the department table, I'll select D dot ID and D dot name as department name, and I'll just put E dot name as employee name. So we have created a normalized table from employee and department table. I'll print it. Okay, so it's telling duplicate column ID. So these two IDs are duplicated. So I will be name it as employee ID here and department ID here. This is the normalized table. For each employee, we have calculated which department he belongs to. So our first step is done. In the second step, what we'll be doing, we'll just finding the ranks. So in the select statement, let me select department name, employee name, salary. Let's make use of dense rank here. So why we are using dense rank? Because of duplicate. For example, here we have 85,000 belongs to two employees, Joe and Randy, right? So we should have the same rank for them. So what dense rank does, if two rows are having the same value, then it will just use the same number, same rank, right? So dense rank over partition by department name, order by salary descending. I'll just put it as RM. I'll run this query. Here you can see 90,000 from Max is the first rank, and 85,000 from Joe and Randy are rank 2. That's the usage of dense rank here. If you are using, if you are not using dense rank, let's assume we are just using rank here, then what we'll get? So we'll skip the row number 3 because two employees having the same rank, then the consecutive number will be skipped, right? But we want to have the consecutive numbers as well. That's the reason we are using dense rank here. So we have got the desired output. So let me create an intermediate city here, and I'll just select the department name, employee name, salary from temp, where rank should lies from 1 to 3. This is our output. For IT department, we got 4 employees, who are the top 3 salary earner, and for the sales department, we got the 2 employee here. This is the common and easy approach, right? Now let's consider the another scenario where we should not use window functions. Let's try to see how we can solve that problem. Before solving, let's make use of this solution to understand how ranking works. For simplicity, I'll just print everything from temp. So if you look at it, what dense rank internally does, it is first creating a partition, just creating a buckets for you, and each bucket, then salary is sorted. So once the salary is sorted, it is having a counter starting from 1, incrementing the counter going forward, right? That's how the ranking function is printing the output here. Let's make use of this logic, and we'll try to create a query without using window functions. That's the first hint, right? Coming to the second hint, so here we are telling row number 1, 2, 2, 3. What do you mean by 1, 2, 2, 3? That means, so if let's say 90,000 is rank 1, that means there is no number which are greater than 90,000, right? Including 90,000, there are no numbers. That's the reason we are getting rank 1. So let's take this scenario 2. So including 85,000, there is one number which is greater than 85,000. So there are two numbers including this number which are having more than 85,000, right? That's why we are having 2 here. Now let's consider 70,000. So there are 1, 2, including this number 3. There are 3 numbers which are greater than or equals to 70,000, right? Let's consider 69,000. So including this number 69,000, so 1, 2, 3, and 4. So what I can tell from this, there are 4 distinct salary including 69,000 which are greater than 69,000 or greater than or equals 69,000 for this department IT. I hope this clears. Let's consider this number 1. So what does this mean? In the sales department, including 80,000, there is no number greater than 80,000, right? That's why we are getting 1 here. If we consider 60,000, so including 60,000 in sales department, there is one number which is 80,000 greater than or equals to 60,000, right? So to simplify this, what I can tell, in the sales department, the total number of unique salaries which are greater than or equals to 60,000 is 2, right? So considering this IT department, the total number of distinct salaries which are greater than or equals to 70,000 is 3. So this 70,000 is 1, 85,000 is 2, and 90,000 is 3. Right? This is the second logic. With this logic, let's try to write our query. I'll make use of this normalized data. Anyway, we need to use this normalized data in our new solution. Now, what I'll do, I'll just select employee ID, employee name. So in the output, we don't need to print employee ID. So let me take employee name, department name, salary. Now let's apply this logic that we discussed before. So we need to count for each salary how many number of distinct salary which is greater than or equals to the current salary. For example, if our cursor is pointing to first row, which is IT department, and let me explain it from here. Let's say our cursor is pointing to first row in this table, Joe 85,000. We need to see how many number of unique salaries are present which are greater than or equal to 85,000 in that department, right? So how we can do? We can make use of correlated subquery. I'll just explain what do we mean by correlated subquery. So here I'll just put select count distinct salary from employee. I'll name this as E here, employee table. Here I'll just put E dot salary, where, so before writing, I will select this from base data. I'll name this as BD here. Now, in our correlated subquery, I am just selecting distinct salary from employee table where E dot salary should be greater than or equals to current row salary. So let's say our cursor is pointing to first row. That means our query is executing the outer, I mean our SQL is executing the outer query. If it is pointing here, this subquery will also run. What it is doing for this salary, we are checking the employees table to count the total number of distinct salary where this salary should be greater than the other employees salary. That's the one thing. And what I need to put, employee dot department ID should be equals to base data dot department ID. So what I'm telling, for each row in base data table, which is the normalized table, I am checking the employees table whose salary are greater than or equals. That's the condition I have written here. So I'm selecting count distinct salary from the employee table where salary should be greater than or equal to this employee salary and they belongs to same department. So this is something very important, right? So we should check only department specific. That's the reason we are putting this condition as well. I'll just put this as RN. I run this query. And for simplicity, I'll order it by RN. I'll order it by RN and department for better clarity. So here for department ID, we have calculated row number one, highest salary, which is belongs to Max, and the second highest salary belongs to two employees, Joe and Randy, for 85,000, and the third highest is 70,000, fourth highest is 69,000. The same goes for sales department as well. So if you look at this output, so whatever we have computed using dense rank matches this uh, output, right? Using the correlated subquery. Now coming to correlated subquery, what do you mean by correlated subquery? So, so I'll just write here subquery. There are two different ways to write subquery. One is just a normal subquery. Second one is correlated subquery. So this normal subquery means the inner query does not depend on outer query. So while creating the execution plan, what SQL engine does, the normal query will be the first query that will be executed because that query does not depend on outer query. So all the nested query will be executed first. Then what we call as a correlated subquery. This means this inner query depends on outer query, right? If you look at our where condition, we are just putting E dot salary should be greater than or equal to BD dot salary and their department should be equals BD dot department, right? This subquery depends on outer query. So how this will be executed by SQL engine? So what it does for every row from the employees table, this subquery will be executed. Right? So since for each row this subquery is executing, we'll be able to count the total number of distinct salary which are more than the employee salary. That's how this correlated subquery works. Now let's make the same calculator intermediate CTE here. And here we don't need to put order by. Just select the employee name, department name, salary from 10, where RN should be less than or equals 3. If you print this output, I'll order by department and salary. The same output what we are expecting here, right? So the first is IT Max 90,000. So the first employee name is Max and he earns 90,000. Then 85,000, 70,000. These four rows belongs to department IT and the remaining two belongs to sales. So this is how we'll be solving. This is one of the way we'll be solving without using window functions here. I hope this video is helpful. Please do subscribe for more interesting videos.